Good afternoon and welcome back. I hope everyone enjoyed lunch and also had a time to look at kind of the posters and talk to some of the PIs upstairs in the room. Before we start our last session of the day, we have two lightning talks for you. One is going to be around cybersecurity and the next will be around cloud computing. So let me turn the mic over to Lena.
Hi, I'm Lena Pons. I am a data scientist with CERT, and I'm going to talk about building knowledge from Inference, logical language models for cybersecurity. So cybersecurity is a problem fundamentally is an intelligence problem. We are trying to extract meaningful information from a sea of sensor data, and we see in cybersecurity that we have a problem of a wealth of data, an abundance of data, and a dearth of insight that we can glean from that data. So in incident response, we're trying to increase the tempo of response and also get ahead of the adversary. One of the challenges that we face in that is that it is very difficult to stay apace with rapidly changing indicators and observables of compromise. One of the things that we then look to is building on techniques from knowledge discovery and information extraction. So this is a field that has had an explosion in the past 10 to 15 years of techniques that build insight and expedite the pace of science, particularly in the biomedical research domain. So when you look at the knowledge discovery literature, there's a strong overrepresentation in biomedical applications for knowledge discovery, and one of the reasons for that is biomedical research has a depth of logical language models describing that domain that we can draw upon. The reason that we have that in biomedical science is that biomedical informatics and library science have also been strongly interrelated, and we have a 150-year history of biomedical informatics as a discipline. So when we think about what the advantage of having these logical language models is really getting ahead of the human capacity for inference from putting together adjacent pieces of information, right? So when we think about discovery, when we think about building knowledge, we think about the idea of combining pieces of information to make an insight, to make a discovery that we haven't been able to do before, right? So when you think about the depth of modeling that you see in understanding how concepts relate to each other in biomedical research space, we are far ahead of the sort of human capacity for inference. And so what you see then is that we are able to make discoveries faster in newer and more innovative ways in the biomedical space that we just do not have access to in cybersecurity because we are missing pieces, right? So if you see in my model, where this is a schematic of sort of the idea of the level of hierarchy that we see in the kinds of language modeling we have for cybersecurity. So what are the limiting factors and what is preventing us from getting there? One of the things is that the information in biomedicine is all accumulative. When we make new discoveries, these are things that are new pieces of information that are integrated into the entirety of our knowledge about medicine. When we think about new pieces of information in cybersecurity, there's sort of there's a timeout, right? We're seeing that information will eventually get stale. So keeping these kinds of deep models up to date in cybersecurity is very difficult and very expensive. And we're already working on trying to stay responsive to attacks that we are seeing in real time. Another challenge, a challenge that I think we have some opportunity to really make headway on, is that the other advantage that you have in biomedicine is that everybody is working from a common set of information. And data sharing in biomedicine is integrated into how we think about moving forward. In cybersecurity, it's very difficult to share information. And there are structural and policy reasons that are inherent to the practice itself. that make building that commonality challenging. However, I think that there are places where we can use innovative techniques in data management to improve our ability to share data in a productive way, to build the kind of commonality that will allow us to build the kinds of models that support inference and knowledge discovery. Thank you.